Ever catch yourself wondering how computers actually, like, make decisions? I
Mm.
mean, they're running on instructions, yeah, but deep down, it's all about logic, right?
Hmm.
And that's what this whole deep dive is about today. Those unsung heroes of the programming world, those logical operators.
Yeah, they might seem kind of basic at first glance, your ands, your ors, a not thrown in there. But honestly, these things are the backbone of how software makes choices, filters out info, even how those targeted ads end up on your screen. It's kind of wild when you think about it.
Okay, so we're talking about more than just telling a computer to add some numbers together. This is like
Yeah.
the logic behind what you see on your screen, what products get recommended to you, that kind of thing.
Exactly. We're diving into some excerpts from a programming textbook, section 3.5, to be precise. And we've got a bunch of interactive coding exercises to really see these operators in action. Should be fun.
So where do we even start? Like you said, the operators themselves seem pretty straightforward, but I have a feeling it gets kind of complicated once you actually start using them.
Well, programmers have these things called truth tables to help visualize all that logic. Might sound a bit intimidating, but they're actually pretty easy to understand, I promise.
All right, let's see what these truth tables are all about. What do they actually tell us?
Basically, they lay out all the possible true or false combinations for a given operator. So for and, both sides of the statement got to be true for the whole thing to be true. Think of it like a two-factor authentication for your code.
Oh, okay, I get it. Like needing both your password and your fingerprint to log in. Makes sense. What about or then? Is that one as strict?
Not quite as strict with or if at least one side of the statement is true, then the whole thing's considered true. Imagine searching for flights you could look for morning or evening departures. Gives you more flexibility.
More options is always good. And then there's not, that one's pretty self-explanatory, right?
Yeah, pretty much. Not just flips the truth value true becomes false, false becomes true. It's basically like hitting that reverse button.
Okay, I think I'm following so far. But how does this all play out in, an actual piece of code? I'm a visual learner. Got to see it in action.
Perfect, because we've got this flowchart from our source material, and it uses a TV channel example to really show how and or work in a program.
Okay, now we're talking. So walk me through this flowchart. What's happening step by step?
So picture this. A user wants to watch a specific channel, they type it in, and the program uses these and or operators to figure out if it should show them a standard definition channel, a high definition one, or if the channel even exists.
So it's kind of like those choose your own adventure books, but for code, right? Based on the channel number, the logic takes you down a different path.
You got it. Let's say someone enters channel 300. First thing the code does is check if that number is within the range for standard definition channels. Let's say channels 2 through 499.
And that's where our trusty and operator comes in, right? Both conditions got to be greater than or equal to 2 and D, less than or equal to 499.
You nailed it. Both of those are true. Boom, the user gets standard definition. But what if they try something like channel 1300? What happens then?
Well, 1300 is definitely not within that 499 range for standard definition, so the and condition fails. So what's next on our logic adventure?
Well, the code then checks if 1300 falls within a different range this time. It's checking the high definition channels. Let's say those are from 1002 to 1499. Again, the and operator swoops in, making sure that channel number is both greater than or equal to 1002 A and D, less than or equal to 1499.
And since 1300 fits those conditions, our and operator gives it the green light. But what if someone enters a totally bogus channel, like 2000?
And that's where that final error output on the flowchart comes in. If the number doesn't meet either of those and conditions well, the program knows it's not a valid channel and throws up an error message.
So it's like and is acting like a bouncer at the club, right? Making sure both those conditions are met before anything gets through. It's amazing how these little operators can be so picky.
Yeah, it's pretty elegant when you think about it. And it gets even cooler when we start talking about how programmers use them to define ranges explicitly, which, looking at these code samples you brought, they do that a lot.
Okay, so I'm sensing the butt coming here.
Yeah.
What's the difference between like implicit and explicit range detection?
So remember that TV channel example? The ranges were kind of baked into the flowchart's logic, right? But sometimes you need to be super specific, like really spell out the exact range you want. That's where explicit range detection comes in.
So instead of just hoping the logic figures it out, you're setting some firm boundaries, right? Give me an example. When would you need to be that specific?
All right, imagine you're building something that needs to flag anyone eligible for a discount. Let's say you have to be at least 18, but younger than 25. You can't just do one check. You need both ends of that range spelled out clearly.
Ah, so you'd use and to connect those, right? Like age 18 and age 25? Is that how it would actually look in the code?
You got it. You're checking the age variable on both ends, making sure it falls within that sweet spot for the discount. And this kind of thing, explicit range detection, it pops up everywhere in programming, validating dates, sorting data, you name it.
This is giving me flashbacks to those logic puzzles you find in escape rooms or some games, you know? You only get to the next step if the previous condition is true. And speaking of taking things to the next level, the textbook also mentions something about nesting these logical operators. Does it get, like, super complicated?
It can, but think of it this way. Imagine you're planning a trip, okay? You gotta book a flight. You gotta figure out where you're staying, which could be a hotel or an Airbnb. A&D, on top of all that, you want to plan some fun stuff to do when you get there.
Okay, I think I see where you're going with this. Each part of my trip planning has its own little set of conditions, and they're all connected by those ands and ors.
Right. Exactly. That's basically what nesting logical operators is all about. You're creating these layers of logic within your code, each with their own ands and ors, to handle those more complex scenarios.
Okay, that analogy actually makes nested logic seem a little less intimidating, I gotta admit. But can we see a real code example, just so I can wrap my head around it?
Absolutely. Let's pull one from the exercises. There's one here where you have to evaluate an expression with a few of these nested conditions. Looks something like this. NumPeople5 and discount code equals true. Okay, just looking at that, I can see how it can get kind of overwhelming. But let's break it down, just like our trip planning. We've got our main condition, that NumPeople5, and then that and connects it to a whole other set of conditions tucked away in those inner parentheses.
You're on a roll. So let's say we have 10 people. The first part, NumPeople5, checks out it's true. But we're not done yet because of that and.
Right. Got to have both sides be true. So now we got to dive into those inner parentheses where things get a little more spicy with that or hanging out in there.
Exactly. The inner part is basically saying the expression's true if either the discount code matches summer 20 or if the user has a premium account. Only one of those needs to be true for that whole intersection to be true.
So even if there's no summer 20 code, the whole thing could still work if that user premium part is true.
Bingo! Think of it like having a backup plan for your trip. Even if that discount code falls through, you've still got those perks if you're a premium member.
Wow, it's like nested logic is hiding a whole decision tree in your code. It's really cool how programmers can put these operators together to deal with those more complicated situations.
It's really at the core of what makes software so powerful, you know? These operators might seem simple on the surface, but they give programmers a crazy amount of control over how a program reacts to different inputs and all those different combinations.
Yeah, this whole deep dive has been a real eye-opener for me. Like, for our listeners out there who might be thinking, okay, this is all cool, but how does this affect me? What would you say to that?
Well, we've talked about online searches, those targeted ads that seem to follow you around, even something as normal as booking a flight or planning a trip, right? Logical operators are like the silent force behind all of that and so much more. It's like every time you're using some kind of software, these operators are probably there in the background, shaping your whole experience.
It's kind of like we uncover this secret language that's actually controlling a lot of our digital world. And the more you understand that language, the more you get how these systems work, how they make choices, even how they can influence our own decisions.
Exactly. Think about all those recommendation algorithms we see everywhere these days, suggesting a new song you might like, a product you might want to buy, even a news article you might find interesting. It's all based on those logical operators. They're analyzing everything, your past behavior, what you like, what you don't like, all to try and predict what you might want next.
It really blows your mind when you really think about it. These tiny operators, and or not, they're the building blocks for these giant complex systems that has such a huge impact on our lives.
It makes you appreciate the power of logic, right? And it shows just how important it is to be aware of how these things work under the hood, even if you're not a programmer yourself.
For sure. So as we're wrapping up this deep dive on logical operators, I think what I'm taking away from this is that these aren't just, abstract concepts that only exist in the world of coding. They're literally shaping our experiences, our choices, even how we see the world in ways we might not even realize.
You said it. So as you keep exploring that digital world, keep an eye out for those ands, ors, and nots. You'll be surprised how often they pop up doing their thing, quietly running the logic that drives our digital lives.
I know I will. Thanks for coming on this journey with me into this fascinating world of logical operators. Until next time, stay curious out there and keep those questions coming.